So, hello guys, welcome to the Amazon ECS Finhack workshop. So, let's wait a couple of minutes to other guy join. You can find link and QR code to the workshop, and you can start with prepare, sign in, login, and etc. So, yeah, hello. Please, guys, say kind of hi in the chat that I can see that you are already here. And yeah, thank you. Hi, guys. So, good. Happy to see you guys. I guess we can start. Yes, sure. Let me provide link to the chat. Let's start. So, first of all, we have to sign in to AWS environment that already prepared for us, for each of us. Let me do it with you. Let me know, please, if you see my screen. I think you should. So go to the one-time password, and then you should check your email. And in the email box, you will get passcode. Wait a couple of seconds, I guess. You should get it. Just one reminder, you should pass your email there. This one that you are using during registration, exactly during registration. So send passcode. And then check your email box. I will you have mine. Just review that agree with term and condition and join them. You should be able to see AWS account access like this one. Open AWS console on the left of the window. And as I mentioned before, this is your account for today's workshop. Please, guys, let me know in the chat that you are already done with this simple task and we can start. So if you get something like not allowed, please check your email that you are using during signing. This should be exactly what you are using before in registration form. Nice. Let's wait a bit till all done with this task. So probably we can start. Hello everyone again. Welcome to the Amazon ECS Finhack workshop. My name is Aliaksandr. I'm system engineer from EPAM Poland, especially Warsaw. And today we are going to on exciting journey to optimize our container cost. So you know how everyone talking about cloud cost optimization those days. Yeah, you're right. Well, we are going to make it happen with containers. We know that our customers are always looking for ways to optimize the infrastructure they pay for, and the containers are not the exception. The purpose of Finhack for Amazon ECS is to introduce lab that enable you to understand what levers are available to optimize computer and operation cost tied to ECS container infrastructure especially. I will also try to make some jokes, but not sure if they will land. Let's see. Sorry in advance for that. Something not happened as you expected. So before we dive in, quick question, guys. How many of you are currently running ECS in production? Please text some kind of hi or plus in the chat. Yeah, till we thinking, guys. Yeah, Alexander, thank you a lot. Senior. If someone still have issue with access to environment, please double check your email. It should be exactly what you are used before in registration form. Yes. Okay, looks like someone already running in production. So this topic will be interesting for you, especially for you guys. So what we are going to talk today? We will cover three main areas. So first of all, it's autoscaling, or how to make your infrastructure flexible. Then cost optimization based on Spot and Graviton. Sorry guys, I need to check. Yeah, thank you. We have support team in the shadow. So thank you guys a lot to help me. So cost optimization and based on Spot and Gravitron, because who doesn't like discount? Yeah, and cost visibility, because you can't optimize what you can see. Cost visibility will have also some scope, like forget right sizing dashboard, and AWS Compute Optimizer and AWS Cost Explorer with ECS stack. So feel free to follow my lead or take the initiative on your own. You can just not wait till I'm doing something and do it yourself without me. In this workshop, we have clear instruction for everyone to follow. So was one important thing to know? Not one, actually a few important things. Firstly, let's start from scaling application section and skip cost visibility, because you can't check something if you don't have something in your ECS cluster. And the second most important, we can see result of Compute Optimizer and Cost Explorer section, because AWS Compute Optimizer requires 24 hours of ECS utilization metrics in the past 14 days to generate recommendation. And it can take up to 20 hours to generate the finding and optimization recommendations. After you create and apply user-defined text to your ECS resources, it can take up to 24 hours also for the tech case to appear and your cost allocation takes activations. So that's mean we will just talk a bit about it and see some screenshots that was prepared already, and that's all. Unfortunately, guys, it will take some time. So let's start from autoscaling. Go to your environment, type in the search cloud 9, or maybe you will see on homepage already. Cloud 9. Go to the cloud 9. There is our environment. So click open. You should be able to see welcome page and terminal, and check that we have right permission to, for example, describe our cluster, and we can to be sure that we have cluster in active status and container inside enable. Let me know, guys, if you are done. Please text to the chat some kind of plus, done, hi, etc. Yeah, thank you, guys. I see. If someone lost something, so I can repeat. It's not too hard, to be honest. Just let me know if you already sign in, open client 9, find the terminal, and see that you have ECS cluster up and running. Command for copy you can find. I guess I can put in the chat to speed up. So let's talk about autoscaling. So ECS service autoscaling scale in out in the ECS task according to the number of tasks that the policy wants. And this is powered by application autoscaling. Application autoscaling is responsible for looking at the historical metrics and performing the necessary computations. Once the target value has been determined, application autoscaling then invoke ECS update service API with the update replica count. AWS ECS service autoscaling supports the following types of automatic scalings. It's a target tracking scaling. This is most usable type of autoscaling. Think of this as your smart thermostat. You set the desired temperature, or in our case, CPU memory utilization, and it handles the rest. Here is what makes it awesome. Set it and forget it. Works great with metrics like CPU and memory. Handles fluctuations smoothly. Built-in cooldown period to prevent thrashing. When someone asks you which scaling type to use, this is usually the answer. So the next one, step scaling. And this is like having manual control over your climate control with specific rules. If temperature 75, add one or two units more. If temperature 85, add 4 more units. More control, but more complexity. Use it when you need to very specific scaling behaviors. Third type is scheduled scaling. It's about perfect for predictable patterns. So it's perfect for predictable patterns. It's running, and when you're running e-commerce site, you can just scale up before Black Friday and scale down after. It's a simple scale. It can be understandable. And one more, in AWS ECS, we have also predictable scaling. There is doesn't any mentioning about it, but we have already, and this one allows you to create predictable scaling policy. This policy enables Amazon ECS to automatically increase or decrease the number of tasks that your service runs based on historical data. So good reading about this one. I will share. I'm sharing actually right now in chat. This is documentation and good post that describe predictable scaling. And also ECS, when we are using EC2 instances instead of Fargate, we also have to think about EC2 auto-scaling. It automatically adjusts the number of EC2 instances in your ECS cluster. There are two ways to handle scaling. Manage scaling. Amazon ECS automatically handles the scaling for you, and you can already think about it. Manual scaling. You manage the scaling action yourself. If you use an auto-scaling group with managed scaling, you set a target utilization present for the EC2 instances. Sorry, guys. Yeah, happens. We all have child and kids a lot. Yeah, sorry, gay. ECS use CloudWatch metrics to track resource usage and adjust the scaling actions based on this. One key metric is called capacity provider reservation, which tell ECS if you need more instances or can you reduce the number of instances. The formula for this you can find in workshop. So where M number of instances needed and number of running instances. And what happens? If M equal N, no scaling is needed. If M more than N, ECS will scale out, add more instances. If M less than N, ECS can scale in, remove existing instances. Also, related with this one, I highly recommend reading this post. Yeah, thank you for understanding. Work from home, it's our real for now. Almost 5 years. So this post has a lot of useful information to dive in behavior of scaling, especially for when we are using EC2 instances. Highly recommend this. So let's try to do something. Let's start with deploy our workload. So easy. You can copy exactly what we have in workshop and paste in. terminal in Cloud9. So we start with creation task definition and some Monte Carlo API service. Then register it. Then before creating ECS service, let's create security group and associate with it. Nice. Then we will create service discovery. We will load traffic through this service discovery endpoint. And then create service. Nice. Let's create application auto-scaling and associate with ECS service. Go to the environment view. Add application auto-scaling. So we give the register scalable target with minimum capacity 1 and max capacity 5. Scaling policy configuration. There is a scale out cooldown and scale in cooldown. About this one, I recommend to check this post. So describe what is it exactly, why we should think about it and use it. And put scaling policy apply to our exist. So to test it, we have to install SIG. And run this command. Let me know, guys, if you are with me. Do you have any issues or not? Maybe I have to repeat something. So go to the thank you, response. You can go to our ECS cluster, go to our service. Oh, we don't have in metrics. So let's check insights. Let's wait a bit. So also guys, I found one interesting post in documentation about optimization of capacity and availability. So how to maximizing scaling speed. Yes, Svetlana, just put one by one in Cloud9 to we have all prepared. So we have ECS cluster, we have needed EIAM policies, roles, etc. So permissions are key. It should work. So main thing from this one about minimize your images size. You know best practice when you create Docker files, you have to minimize run levels and try to use image less less as possible. Also minimal image from start from scratch. Keep your images closure. So recommendations is using Amazon ECR and about also mentioned about cross-region replication, reduce load balancer health check thresholds if it's possible, consider cold start performance, especially for Java performance, and use step scaling, not target tracking scales possible. It's also can be why not. So check this post attentively. It will help to maximize scaling speed. So let's check our environment that we have. So CPU is so high. Let's check how autoscaling works. Still more. Let's wait a bit. So we can check our policy is active. No schedule actions. What we have that autoscaling is working already. In events, we can see what's going on right now, how ECS autoscaling works. Yeah, cool, nice. So right now we have max of desire number changed to 5 and we have 5 containers are up and running. Let's stop our loss Overload. Okay. Yeah, just to finish the load test again, I can repeat. Stop our tool with pressing Ctrl C. Also, guys, during we are waiting till ECS autoscaling will down our containers, I recommend to check next post. So this is a kind of sum up of best practice Amazon ECS scaling. So this is big post that describe in details how it works, how we can optimize it. I can do just a quick sum up. So application first, focus on your application resource needed rather than just infrastructure. Design services to scale efficiently based on CPU, memory, and network use. Also, set the correct CPU and memory limits for your containers. Avoid over-provisioning, wasting resources, and under-provisioning, performance issue. It's not easy to find this gold balance between over-provisioning and under-provisioning, but if you have good performance test and good observability, it's possible to find it. And you should review your current state probably every week or every month, depends on how fast your CI/CD and how often you deploy to production. And also use ECS service autoscaling to dynamically adjust the number of running tasks, set scaling policies based on CloudWatch metrics like CPU memory or custom metrics. Ensure your ECS cluster has enough EC2 instances of Fargate capacity to scale. Sorry, guys.
Я не могу поиграть, потом он убежал опять смотреть мультик, потом выключил компьютер, опять одеяло, ладно.
Sorry, guys. It's work from home. And so where are we stopped? Yeah. Ensure your ECS cluster has enough EC2 instances of Fargate capacity to scale. Use ECS cluster autoscaling to manage EC2 instance scaling automatically. Consider capacity providers for flexible computer options between EC2 and Fargate. Distribute traffic across tasking using application load balancer, and the network load balancer. Use dynamic port mapping to maximize container density on EC2 instances. Probably by following this best practice, you can build an efficient, cost-effective, and scalable ECS environment that adapts to demand, to your demand. So highly recommend it. Let's check our environment. It will take more time than scale in than scale out. So we can check in metrics. Yeah, we have CPU utilization 1137 till 941. It can take around 10 or even 15 minutes to scale down. I guess we can proceed. Then we'll return to check. Let's proceed with Spot. So now that we have mastered scaling, let's talk about saving money. Most important task. Who like discount, guys? Please text plus or minus in the chat. Everybody. Yeah, okay, you're right. So Spot, it's like about discount. It's not full accessible. It's not about that you can use every time. But if you prepare your application to use it, you must use it. Maybe partly in your infrastructure. So up to 90% cheaper than on demand. Perfect for fault toleration workloads. But you might need to move with some with full price ticket comes along. So if someone pay more than you when you're using Spot instances, you have to be ready go on from some load. But anyway, 2 minutes waiting notice before interruption is like getting that final boarding call. So you will get notification that you have to go on. Let's continue with. Before we continue, we can check what we have right now. Still running. Okay. So the same AWS Client 9. Put cluster capacity providers. And we will change it with weight and base. So what does it mean? Base and weight. So for example, base 3, at least 3 tasks will always run on regular Fargate. So if we have 2 tasks, we will use Fargate. If we have 3 tasks, it will use Fargate. If we have 4 tasks, 3 tasks will use Fargate. The rest one will use Fargate Spot. Weight, it's about for every one regular Fargate task, we will try to run 2 on the spot. It's about like think of it at having one backup generator, regular Fargate, and 3 solar panels, spot. Most of the time you will use the cheaper option, but if you have got backup, you can use it when you need it. So we don't need setup environment. One thing that we have to up one level before run this command. Be aware, guys, we already in environment directory. Please go to the home directory. And register that definition. No such file to. Sorry, guys. Yeah, my bad. We can do it in our environment because we have full pass. Sorry. Now let's continue. Create ECS service. And we can check describe task. Let's wait a bit. Yeah. Let's see in console what we have here. Services in flight. Deployment still in progress. Let's wait a bit. Complete. Yeah, you can see that we have 4 containers running on Fargate and 2 on Fargate spot. This is how base and wait works. We set base for on demand to 3 with wait 1, and for spot we set wait to 2. Based on the value of base, the first 3 tasks were deployed as on demand, and the remaining 3 were deployed according to the weight of on demand and spot. This is how it works. Let's proceed. With Graviton. So it's a kind of AWS secret weapon in the processor world. But just imagine if you could get better performance and save money. Looks like Graviton is your option. You can save up to 40% better price performance. This is ARM-based architecture and perfect for containerized workloads. It's a kind of, I don't know, real world, it's a kind of hybrid car. Better performance, better efficiency, and better for your wallet. Let's try to deploy something with Graviton. So we have already prepared environment. Just run step by step. Create task definition, distribute this task, and create service base. This task definition. Let's check our cluster. One more services, inflow Graviton, still in progress. Already have something. Yeah, we can check the architecture of one task is ARM 64. Yeah. So we are done. We have advanced task to build multi-architecture container image, but it's not exactly scope of this workshop. You can do it by yourself in the shadow. It's easy. It's just Terraform applied already exists. That already exists, and then see that we have multi-architecture container running. Nothing interesting. Let's return to cost visibility. So we already done with some optimization of our infrastructure. Let's talk about tracking those savings, not about using CLI commands and checking ECS AWS console. We can use some powerful tools like forget right sizing dashboard, and we will see how looks AWS Computer Optimizer and Cost Explorer with the ECS tags. So let's check these dashboards. Please find this section. I can share the chat. Create service. I already done this workload a few times. If you have some errors or exceptions, just try to repeat step by step. There is a link. This is most interesting part, to be honest. Let's go to another folder, to home, cloning, go to, and we have to change cluster name with our. You can try to do the same in your environment. I mean, on your projects, on your own, after workshop. Just be aware that you should have to change cluster name in the JSON. .json, I mean. Then we'll create dashboard. Let's find this one in CloudWatch. Dashboard. Forget right sizing. $35. So this is how it looks. Not so many graphs, beautiful graphs, but in production I tested it. You can easy to find which container most waste of CPU and memory. So especially for, we have separate dashboards for memory and for CPU. So for now, it looks like almost all our containers are waste CPU and memory. And some details like average, peak is also useful information. Because you can see if average LED, then we want, but sometimes we have peak 100s. We should check it and think how we should catch it in our settings. I mean, minimal capacity, some cooldown periods, etc. Also, in this Git repository, you can find not only right sizing, you can find container level metrics. It also works, and it will help to investigate what's going on in your service. For example, if you have 5 sidecars like we have in our production for each service, it can be kind of OpenTelemetry hotel collector, then it can be some kind of secret update, it can be invoice sidecar, um, and some AWS Guard duty, etc. So 5 containers in one task. This dashboard can help to investigate what's going on, how many resources you should add. Even you can find right priority during start our service. So some containers need more resources from start, and then less. So probably it should be first candidate to start. Just for your eyes, guys. So that's all about this 2 dashboard that I can see. And our list stuff, it's AWS Computer Optimizer. So before you can use it, you have to enable it. It's easy to do. Let's find it. AWS Computer Optimizer. Get started. This is ECS for gateway stage, but as I mentioned before, we have to wait more than 24 hours but able to see any recommendation. Yeah. How it will look, something like this one. Some findings with over provisioned and memory over provisioned, and there is a recommendation to optimize it to make it less than right now. You can see current settings in details and recommendation and how many you can save per hour. Good place from your managers to show it. Then you find it and follow recommendation. Just update your task or your deployment in Terraform. And then recommendation will check it again and use it. Everything is fine. Update and then done. And the last one, Cost Explorer with ECS task. Again, we go to AWS Cloud9. Let's do environment. One massage. This one. Create. Write permission. And then just run it. And if you want to enable tech propagation, you have to create one more script. So I am to check, looks like, yeah, the first is empty. Let's run first. Let's run second. And this for our billing. Cost allocations tax. Yeah, this one. But as I mentioned before, we can check it after 24 hours. How it will look, it will be like you can find your resources that you marked by tag, and then you can review cost in Cost Explorer only for this one. It will help to investigate and know what we are using. Not, it's a kind of custom mark for your resources in AWS, because in Cost Explorer you can try to find by services, by API calls, and sometimes it's not useful to understand what's going on and how many cost we have in our environment and what we are using right now, and how to reduce it. The main question, how to reduce it. So cost tech allocations, it's our main tool in this one. So, all right, let's recap our container cost optimization journey and what we have covered. Auto-scaling, the main topic. Target tracking is your friend. Scale out fast, scale in slow. Always set appropriate cooldown periods. For computer optimization, spot instances, try to use Graviton, but guys, one tip that you have to test your application carefully and a lot before using Graviton to avoid any issues in production, and try to use stateless before anything else. And the power, it's a combo when you're using Spot and Graviton to reduce your cost. And cost visibility, right sizing dashboard, try it. Maybe you can adjust it to your environment and optimize it or share. Try to use computer optimizer to check how it works for ECS, to get any recommendations. And you must have to use Cost Explorer these days. Now, guys, I guess your turn. Maybe you have some questions. Remember, there are no silly questions. It's only mine speech can be silly, or our containers or optimizations. Please ask something. If container level require container inside. Yes, exactly. You're right. Without this one, it's impossible to check these metrics. How ECS observability works, especially. You can remember that we are checking cluster settings at the start of workshop and see that container inside was enabled. Anything else, guys? So if no questions, guys, before you go, there is a link with feedback, please. Please take a moment to fill out the workshop feedback form, because it's important for us for improving next workshop and grab some statistics, how it was it interesting, should we change something, etc. Thank you in advance. And feel free to contact with me in LinkedIn. Don't hesitate. If you have even any questions, I will try to help or answer or support. So thank you for your time. We will close our workshop. Thank you a lot again, guys, and good luck. See you.